Hello everyone, and this time I'm gonna show you how you can simulate the Monte Carlo calculation using the provided Excel sheet. First thing to do is you just downloaded those add-in program, the ran_bar.xla. This is add-in program. This is is a folder, so you just click inside here, and you can find this XLA, the add-in. So you should have these types of subprogram to run the simulation, the Monte Carlo simulation. Okay. So once you actually download this folder and along with your engineering calculation sheet, first things to do that you just launching those add-in program first. Yeah, it takes time, so just wait. Yeah, sorry, it takes so much time now. But yeah, once you get this pop-up message, you just enable macro, and then you actually pop up this type of additional section here at the end. Yeah, you have ORMM, so that actually successfully installed your add-in program here. So to remind, don't close of this program before you starting your engineering calculation. Just to minimize, okay? Just minimize this your add-in program, and you go back and your original folder. And I'm gonna show you two different examples. The first example is actually showing the retaining wall external stability calculation. This spreadsheet is actually for engineering calculation sheet. So whatever you calculated the factor of safety value from your input parameter, your external, the T-shape of external, the stability wall, your input parameter is phi, and actually the unit weight, and your the subgrade the soil parameter, shear strength parameter, the cohesion, and the friction angle. So, and those, and in the engineering calculation sheet, we just focusing only here is the sliding failure mode. So among those external stability, overturning, and the bearing, we are just focusing the sliding factor of safety here. Okay, so this is our target in the calculation. First thing to do is you need to assign those two the subgrade soil parameter, shear strength value. So those two input parameter, drain parameters, you actually consider as a random variable. So that's how you actually define in this normal engineering calculation sheet in this input parameter as a random variable. The first thing to do is first you designate the phi and the cohesion, two random variables the top of here. So any place, so you just define those random variables. The click your actually M1 is you set the location of your starting point of the assembly table random variable, and go to add in, and you just define the add RB. Because you previously clicked the M1 before, so you automatically assign the cell here. That's the starting point of your the table value, and your random variable is now pi. And we just using the beta distribution here, and the Gaussian distribution. So we already defined that your alpha beta value is 11, and low value is actually 16 degree. Oh, sorry, this is 16. Maximum is 26. Okay, and the vertical shapes of a table, Okay, it's okay, and then you define, because you already assigned these pies before, so that's really fine. Okay. And the second random variable cohesion, you also start the same procedure, add an RB. Now this is a cohesion, and the beta is 11, and this type, the lowest value is 100 PSF, and the upper value is 100. Okay, it's okay. Let's define. And don't forget, you actually your input parameter values are placed here in the. You should designate which parameters we used in your Monte Carlo simulation. Those two parameters assigned as a random variable, right? So you just designated these two in random variable, and you define like a RV underscore sim v cohesion. This is for cohesion random variable. This is a pi, is a friction angle random variable. So you should actually, designate this RV sim the function and those two random variable location. So don't forget that. And you actually click the B. Yeah, so this is your output, right? It's factor of safety against the sliding. So you designated output value, and then you go back the program. Now you just calculation the Monte Carlo, the simulate RV. So you already pointing this cell values are pre-assigned, and your starting point, the output value table is a B70 cell number. Okay. And I recommend your Monte Carlo simulation iteration number maybe just 500 instead of 100, and the repeating cycle is a 2. And you can designate 3 and 4, but it takes much more time. And you just by default click is just leave like that, and your chart type is column shapes. Okay, you designate like this, and then maybe you can change your random variable, maybe factor of safety FS, or just leave like that automatically, sim B65, whatever. Okay, just now is ready to simulation. And yeah, so it's actually showing that the factor of safety value is preliminary, showing the ranges 1.24 to 1.227, close to 7. Yes, between the ranges actually a histogram may be showing the output value. So maybe I agree. You agree the minimum, maximum, upper, lower limit, and the histogram, the interval numbers 10 maybe is more actually simplified the graph. Okay, then you can see that its calculation is going Monte Carlo simulations. So its input variable is a change over P and the cohesion, and also it changes that vector of safety values accordingly. And now actually that is the output value as it comes up here. So you don't like this type histogram, the graph, you can just delete this form, and then you just add it maybe different types of a graph. So it's insert, maybe the different shapes. Yeah, so maybe you can just plot this the output value. It's a close Gaussian distribution over your factor of safety. Okay. That's the first demonstration. So we close it. And I'm going to show you the next demonstration. It's cumbersome. Second demonstration, you're also launching the first at the add-in program. It's a little cumbersome because it's a free software, but whatever it requires, so you just follow the sequence. So first things you do the launching this add-in program. And then the next step is you just launching the engineering calculation sheet for your Monte Carlo simulation. Okay, you enable a macro, and you confirm this section is generated, and then you minimize, not close, and then you go back, and your actual engineering calculation sheet, the settlement calculation. The second example is showing the secondary settlement calculation. So yeah, I already explained that detailed process in the week 4 presentation. And this spreadsheet actually using the calculation of your secondary settlement amount. So this you know the formula. The input parameter is the NW primary the void ratio, and C sub alpha at the creep the consolidation coefficient, and T actually 1 is actually the end of the primary settlement time. So those 3 random variables are usually predefined. And from the experiment, I think you just maybe the relevant beta parameter to matching this data distribution shape. So yeah, creep and the coefficient consolidation, the secondary consolidation parameter, and then the primary consolidation time is each peculiar to different shapes, right? So you should assign the different beta parameter, and then so your target is actually how you get this secondary settlement based on this input parameter distribution, right? So you actually output value will be this value secondary settlement formula. So you click the first here, then you actually know that where to put the output value table. The output value tell you the starting from the B to 25. So you go to add-in, and then now so you predefined that or the random variable. So just we skipped those 3 steps, and we just directly go to the simulator random variables process. So I pre-assigned this what is target value of your what is for your Monte Carlo simulation output will be. So your secondary settlement amount, right? So that's B6, and your result is starting from the B25, and I recommend this your simulation number is maybe increase to 500, and the repeating is 2. That's enough. So you can increase 2 or 3, 4, but you will take increasing your also simulation calculation time as necessary accordingly. And the chart type column, okay, and then go ahead. So that's your actually the settlement calculation output. The previously is calculated, and as make the graph. So I'm gonna show how actually the output values will appear. Yeah, it takes the time, and also it's showing the minimum and the maximum the calculation amount, secondary settlement amount. So 0.2 is a 0.6 inch, and number of cells is 50 is too much, so you just decrease. It's 10. Okay. Now it's calculation, right? So different 3 the input parameter, and then its secondary settlement amount is also calculated. Okay, and then it's showing that this is a resultant histogram. Yeah, so maybe you can change that histogram is not like this format. You can just either remove this type, and then you set this value, and you plot maybe some different types of the graph, like a line. Okay, so that's it. So I just briefly to show you how to play your Excel sheet with the add-in program in the Excel, and enjoy, and feel free to give any question and leave your comment in the forum. Okay, thank you.